Welcome to Building Materials Testing Laboratory. Today we are going to conduct an experiment to determine the bulk density of fine aggregates. The apparatus required to conduct these experiments are balance, cylindrical container and tamping rod. Bulk density clearly depends on how densely the aggregates are packed. For a material of a given specific gravity, the bulk density depends on the size distribution and shape of particles. When aggregate is to be actually batched by volume, it is necessary to know the weight of the aggregate that would fill a container of unit volume. This is known as bulk density of aggregate, and this density is used to convert the quantities by weight to quantities by volume. What is the procedure to determine the bulk density of fine aggregate? Bulk density of fine aggregate can be determined in two different states. One is the compact state and the other one is the loose state. Depending on the size of the testing aggregates, the size of the container is taken. Basically, the container is calibrated. That means its diameter and its height will be noted down along with the empty weight of the container. In terms of the compact state, the dried aggregates are filled in 3 layers into the container, and each layer is compacted uniformly using tamping rod of 10 mm diameter with 25 blows to each layer. After the aggregate is completely filled in container, weight of the aggregate with container is measured and it is noted as W2. In terms of the loose state, the container is filled to overflowing by means of a shovel or scoop, the aggregates being discharged from a height of not exceeding 5 cm above the type of the container. The surface is then leveled using a straight edge. The net weight of aggregate is noted down as W3. This is how the container is going to be looked. The observation and calculation related to this particular experiment is basically we have to note down the inner to inner diameter of the container and inner to inner height of the container, through which we can calculate the volume of the container using the formula V is equal to pi d square by 4 into H. Later on, the bulk density is calculated by the formula weight of the fine aggregates divided by volume of the container. In terms of dense states, weight of the container plus densely filled soil minus the weight of the empty container divided by the volume of container gives the bulk density of fine aggregates in dense state. Similarly, in terms of loose state, the empty weight of the container plus the loose soil minus the empty weight of the container divided by the volume of the container gives the density of the fine aggregates in loose states. The equipment used to determine the bulk density of the fine aggregates. This is the container in which the fine aggregates is going to be filled, and using this stamping rod, number of blows will be provided in filling the fine aggregates. The inner to inner diameter of the cylinder is measured using the vernier calipers, and the inner to inner height of the container is measured using the steel scale. Note down the inner to inner diameter of the container using the vernier calipers and make sure that when the two edges comes in contact with the container, using this screw it is locked. Note down the MSR and CVST of the vernier calipers to calculate the inner diameter of the container. Note down the height of the container using the steel scale. Once the inner to inner diameter and height of the container is measured, note down the empty weight of the container. For the compact state, fill the container with fine aggregates in 3 layers and make sure that each layer is provided with 25 blows. In the same manner, make sure the container is filled with fine aggregates in another 2 layers and each layer is compacted with 25 blows. Make sure the container is filled with fine aggregates in 3 layers and the excess mass is removed from the top surface and its weight is measured. Once the container is filled with fine aggregates, its weight is measured as W2. With respect to loose state, the container is filled with fine aggregates without compaction. That means there will be no division of layers. The container will be filled up to the top and the excess will be straightened up and its weight is going to be measured. In loose state, the container is filled with fine aggregates without any layers, and once it is filled up to the top, its weight is measured, and note down the weight as W3. Now let us come to the determination of bulk density of fine aggregates calculation. The initial readings to be noted down are the inner diameter of the container using vernier calipers, and it has given us a value of 15 cm. Using vernier calipers, the diameter is calculated by the formula MSR plus CVSD multiplied by the least count. The inner height of the container is calculated using a steel scale whose value is 17 cm. By using the diameter of the container and the height of the container, the volume of the container is given by the formula pi d square by 4 into h, which gives us a value 3002.625 cm cube. After the noting down of inner diameter and height, the empty weight of the container is noted down, whose value is 3140 grams. Next, with respect to the compact state, weight of the container per compacted fine aggregate gives us a value of 8390 grams. The weight of the compacted fine aggregate is W2 minus W1, whose value is 8390 minus 3140, which gives us a value of 5250 grams. Therefore, bulk density of the fine aggregates in compact state is given by the formula W2 minus W1 divided by V, where W2 minus W1 is equal to 5250 gram and V is equal to 3002.625 centimeter cube, whose value is 1.7485 gram per centimeter cube or 1748.47 kg per meter cube. With respect to the bulk density of fine aggregates in loose state, weight of container plus loose fine aggregate, which is represented as W3, is noted as 7734 gram. Weight of loose fine aggregates is equal to W3 minus W1, that is 7734 minus 3140, which gives us a value of 4594 gram. Therefore, bulk density of fine aggregates in loose state is equal to W3 minus W1 divided by V, where W3 minus W1 is equal to 4594 divided by V is 3002.625, which gives us a value of 1.53 gram per centimeter cube or 1530.00 kg per meter cube. Similarly, 3 trials has to be conducted and average of 3 trials has to be considered as the bulk density of fine aggregates for compact state and loose state. Thank you.